Be talking about the use of sliders in GeoGebra, and as an example we're going to be using the quadratic function. And so what we did is we created sliders for our values of a, b, and c. Okay, our variables in the quadratic function, as you can see over here. Since we have b and c set to 0, our equation at the moment is just 1x squared, which is the parent function. And as we change values on the sliders, then our equation of our quadratic changes. So we can change a, we can change the value of b, and the value of c. Okay, and let's expand that a little bit. And so you can see how our function changes. Now, the question is, of course, is what effect do changing the values of a, b, and c have on our quadratic function? So what I'm going to do is I'm going to set b and c back to 0 real quick, and set our a value to 1. Okay, and like I said, this is what's called the parent function. Okay, so any kind of transformation that we do will be based off of this parent function. Now, changing the value of just a, sliding it up or down, is either going to make it wider or narrower. Now, contrary to what a lot of students believe, as we increase the value of a, okay, the graph of our quadratic is actually going to become more narrow. So you can see as the slider moves to the right and we get a more positive value, that our graph becomes narrower. And I explain this to them because what's happening is that for each of our x values, we're multiplying it by that new a value, and that's giving us our y value. So let's say x is only equal to 1. Well, then that means that way up here at 10, for the y value is where x is going to be equal to 1. So that's why the graph becomes more narrow. And as you can see, as we decrease the a value, our graph becomes wider. Okay? Now it's only going to get wide to a certain point, because eventually, if our a value goes to 0, well, then we no longer have a quadratic function. So let's say, let's take it down to 0. You notice that it becomes flatter or wider. Well, it's going to get to a point where it becomes a straight line, because the quadratic part is null and void because it's 0. Okay, and so what we have is a line, and the line has 0 slope and it has a y-intercept at 0. So all we have at that point is going to be a line that goes along the x-axis. If we continue to decrease the a value and give it negative values, then what it's going to do is reflect over the x-axis. So let's say we go down to a is equal to -1, then we're going to have a graph that looks identical to the one that we started out with, our parent function, with the only difference being that it's reflected over the x-axis. Okay, so that's going to be our change that the a value has on it. It's going to make the graph either what we call wider or narrower based on the values, and if it's negative, if our a is negative, then we're going to have a reflection and it's going to open downward. So let's set that back to a is equal to 1. So we have just 1x squared. Okay, now we're going to skip to the c part. Okay, c is going to be, that's going to affect our vertical shift, either up or down. So you notice as we increase c, the shape of the graph doesn't change at all. But now that I have a c equal to 4, I have a vertex that's up here at 4. Okay, a y value of 4. The x value is still 0, of course. So all that c does is just create a vertical shift, either up or down. Has no effect on the overall shape of our parabola. Doesn't make it wider or narrower or anything like that. Doesn't move it left and right. Just strictly a vertical shift. Okay, so if we always look at the c value, then we know where this is going to be. Now this is given that b is equal to 0, of course, at the moment. Okay, so let's move the c back over so that our vertex is at 0, 0. Okay, so we're back to our parent function. Now the b slider is what confuses people a lot, because a lot of students will assume that if c moves it up and down, that b must move it left and right. Well, it moves it left and right, but it also moves it up and down at the same time. But it's not linear. What it does is it follows a parabolic trajectory. Okay, so you're going to notice that as we increase b, that our graph is following this trajectory, still passing through the origin at all times as it increases, but it's moving to the left and down. And then as we decrease b, okay, get into negative values, it's going to move or follow a path that goes down and to the right. Okay, and so this is one of the more confusing things about the quadratics for students. Well, the reason is, without getting too in depth in this lecture, is because if we looked at the various equations that we use, a standard form, a vertex form, etc., we can find that the value of the value of b is equal to negative 2 ah. Okay, with h of course being the x value of our vertex. Alright, well, if we solve that for h just becomes negative b over 2a. So that means that if I take, let's move it out, that let's say I increase my b value to 2. Okay, so we now have a b value of 2. Alright, well, according to this formula here, with a b value of 2 and an a value of 1, my h value, or the x value of my vertex, would now be where? Well, it would be negative 2 over 2, which would put it at negative 1. And if you look, that's where the x value of the vertex now is. It's going to be down here at negative 1. Okay, so b changes it parabolically, or as far as the trajectory that it takes. Alright, so this is an awesome tool for teaching that to students, because they can see that it continues to maintain going through here. Now the thing is that we didn't change our c value. Now if I change c, of course, let's say make c equal to 1. Okay, well, now it's going to follow a trajectory, but it's going to pass through this point 0, 1 all the time. Or not all the time, I should say, but it's going to follow that path. Or excuse me, I'm continuing to change the c. My bad. Let's get c back at 1. Maybe that looked wrong. And click on the b. And now you're going to see that it follows a parabolic trajectory going through the point 0, 1. Okay, so that's the way that the values of a, b, and c influence the shape. So of course we can continue to make the graph narrower or wider. We can reflect it. Okay, so let's say we make a equal to 3. It's going to give us a narrower graph. Let's say we have b equal to, we'll make b equal to 3, and let's even make c equal to 3. Well, we know that that's going to shift it up. So now we have 3x squared plus 3x plus 3. So our graph, of course, has become more narrow. It's shifted up 3 units, but it's also followed the parabolic curve because of the change in the b value. Okay, so next we're going to look at the discriminant, which is our value, the square root of b squared minus 4ac. Okay, so looking at the discriminant. By looking at the discriminant, you can analyze what the graph is going to look like as far as its location on the x and y axis, so on the coordinate plane. Alright, so we have our quadratic formula down here, negative b plus or minus square root of b squared minus 4ac all over 2a. Okay, the discriminant part that we're worried about, or that we analyze, is just going to be this part here, the square root of b squared minus 4ac. By looking at that, we can tell how many real roots or real zeros we're going to have. How many times does it touch or cross the x-axis? Okay, and the way we do that is because, of course, if we have a positive value, okay, if there's a positive value in our discriminant, well then when we take the square root of the positive, we are going to have a positive value. Since we are both adding and subtracting from negative b, that can give us two different values. If we have two different values over 2a, well then we're going to have two roots. So let's take a look and say, let's say b is equal to 2. We'll keep it easy. And we could say c is equal to 0.5. Okay, and a is equal to 1. Alright, let's show all of that. Okay, so with this formula, with 1x squared plus 2x and plus 0.5, we're going to have a positive discriminant, because 2 squared is going to be 4 minus 4 times 1 times 0.5. Well, that's going to be 2, so we're going to have the square root of 2 as our discriminant. It's a positive value. And if you look at the graph, you're going to notice that when you have a positive value, we have two real zeros. We have two places where the parabola is going to cross the x-axis. Okay, so that holds true, and you could try it for different values. So let's try a negative. Let's say our c value is 2. Okay, well, with a c value of 2, what we now have is 2 squared, which is still going to be 4, minus 4 times 1 times 2. So what we end up with is 4 minus 8, which is going to give us negative 4. Well, of course, if we try to take the square root of a negative, we're going to have imaginary numbers. Okay, this means that our answers are going to be imaginary. Okay, we're going to have two solutions, but they're both imaginary. They always come in pairs. And of course, if we look at the graph, we can see that there is no place that this parabola, since it opens upward and the vertex is above the x-axis, is going to cross the x-axis. Okay, at no point. So we have two solutions, but they are imaginary. They're non-real numbers. Okay, now what if the discriminant is equal to 0? Where would the graph be located? Well, when it was positive, and we're looking at just a positive value of a in these, just opening upward. When the discriminant was positive, we had 2 roots. When the discriminant was negative, we had 0 roots. Okay, well, at most, a quadratic can only have 2 roots, so we have to have either 0, 1, or 2. So if we take c and let's make c equal to 1. Okay, well, now we're going to have 2 squared minus 4 times 1 times 1. So we end up with just 4 minus 4, or the square root of 0. Well, the square root of 0 is just 0, which means that really all we're going to have is the negative value of b over 2 times a, which of course is going to be 1, because we're going to have negative 2 over 2 times 1. So it's going to give us negative 1. And so now if we look, when the discriminant is 0, our vertex is going to be right here at negative 1. Okay, so when your discriminant is 0, you only have one solution. It doesn't cross the x-axis, but it does touch the x-axis at that point. Okay? Okay, almost forgot one part there. we also want to look at what is the what if the discriminant is a perfect square. Okay, so let's plug one of those in. So in order for this to be a perfect square, let's kind of change some values here. Let's make this, let's see, okay, let's make the b equal to 3, and let's make our c value equal to 1.25. Okay? Alright, by doing it this way, if our b is equal to 3, well then our b squared, or let's just look at the discriminant part, our b squared is going to be 9. Okay, let me zoom in on that. Okay, minus 4 times a times c. Well, 4 times a is going to be 1, and then times c, you get, or excuse me, 4 times a is going to be 4 times c, which is 1.25, so you're going to have 5. Okay, well, if I have 9 minus 5, it's going to be 4, so what we're going to end up with is a perfect square, the square root of 4. The only thing that's different, now we're still going to have 2 roots, or 2 solutions, but the only thing that's different is that if it's a perfect square, we know that we're going to have rational solutions. Okay, because when I take the square root of 4, I'm going to have negative 3 plus 4 over 2. So I'm going to have 1/2. Okay, or negative 3 minus 4 over 2. Okay, so negative 7/2. Okay, so negative 1/2 or negative 7/2. You have a rational solution. Now if I changed any of these, okay, and just changed a little to where the discriminant is no longer a perfect square, do we still have 2 solutions? Yes, we do. Okay, because it's still a positive number. The only difference now is that when we find our solutions, they're going to be irrational numbers. Alright, and next video will be on part 2.